Good evening, all. So I hope all of you have completed the quiz and have joined for the session. Okay, so let's start today's session. Today, actually, we'll not be having any classes. Rather, we'll be having a general session. So, so like throughout this exposure, you must have come across various kinds of sessions, and that might have given you an idea of how the industry is going on, like how the works are being carried out in the industry. So today, a general session about how to carry out a research work will be explained, and, and I'll just share my screen. Okay, so I hope my screen is visible. Okay, this session actually about the how the research work is being carried out. Actually, it will be defined with my own project. Okay, so I'll be explaining it how my research work in MTech level has been completed. So the project topic was assessment of erosion control on field soils. So basically, it was a study combining both experimental and numerical data, and I have carried out in my MTech project. Actually, for the final year, we're having this project, and compared to the BTech project, MTech project is having more weightage, and so importance is also more. So moving on to the contents of my presentation, it includes problem statement of significance, so introduction of the work and objective, materials, methodology, result and discussion, scope for future research, conclusion, references, publication and awards. Okay, so moving on to the problem statement, basically, I hope all of you are familiar of the term erosion. So erosion, uh, in my study, actually, I'm focusing on coastal erosion. That is the erosion caused due to the attack of waves or the erosion which is caused in the coastal regions. So we all know that coastal erosion, basically in our state, Kerala, you all must have, you all might have heard of different problems even in these recent days, like Chellanam and Virinam, all these protests you must have heard of. So all those were related to related to coastal erosion. So it is basically a major concern of all the coastal district. And in our state also, Kerala is very much dependent on coastal people, like fishermen, etc. So this topic is very much important to regarding our it is a very much important regarding our state. Okay. So in my study, actually, I've carried out in the Trivandrum district. So it can vary from different district, like Kozhikode and Trivandrum, Ernakulam. Different regions might be having different amount of erosion, and for that you have to carry out the study in different parts of the state. Okay. Now, moving on to the introduction, soil erosion, you all will be familiar of. Basically, it is a widespread form of soil degradation, and it can be experienced anywhere in the world. Okay, so when we look onto the data, among the 590-kilometer coastal stretch, almost 53 kilometers of the coastline has been under the vulnerable category. So that is, it is under serious threat of erosion. So the next 243 kilometer will be under the semi-vulnerable category, and 41% of Kerala's coastline is under severe erosion threat. So this was based on the study that has been conducted in the year 2021, and each year actually the amount of erosion is being increased. So we have to look on to various measures on how to protect our coastal line. So that is very important. So that is the basic need of such a study. So these are some of the images that are caused due to erosion. So erosion actually it occurs due to two factors. Erosion can occur due to various factors like wind, water, etc. And the erosion which is caused by water itself can be classified into erosion caused due to rainfall or wave attack. Okay. So the erosion which is occurring due to rainfall will be when when like flash floods are occurring or high amount of rainfall is being occurred. So landslide, etc., will be developed due to that rainfall, and so on. And similarly, wave attack will be causing coastal erosion. So in the image, you can see a landslide which is caused due to high amount of rainfall. Okay, these are some of the images which are caused due to the attack of the waves, and you can see how disastrous the waves are. Okay, like firstly, when we're carrying out a study, like we have to look on to reliable data. So even in our Kerala government website, we can see various erosion datas, landslide datas. We can identify the hotspots like erosion hotspots and the areas which are prone to landslide, flood, drought, etc. Even in Kerala website data itself, you can identify. Or further, in order, if you have to develop your studies more, you can rely on any other softwares like GIS and so on, like in order to map uh, the locations accurately. Okay, so the first step of doing a research is actually you have to look onto data and then you have to identify the gaps. Gaps meaning gaps are actually what you use to develop your work. So when you go through the literatures, actually we'll be getting familiarized with how the works are being carried out, and then after that, referring them, you can identify the gap. Like suppose a particular work has been conducted on like maybe northern side of our country, then we can think of if like how we can adopt that in our particular region. Will it be possible? Like all those possibilities you can analyze. That is actually the basic step of identifying gaps. So when I carried out this literature study, I have come across like various gaps, and these are the gaps that I have identified. That is, like I have selected two regions for my study. That is Menamkulam and Poontura region. Both are in the Trivandrum district itself, and then I have carried out my experiments on those two regions. Okay, and also I have analyzed the effect of varying wave actions in the coastal region and the effect of chitos and how it can minimize the amount of erosion and how coir geotextile can be applied in order to reduce the erosion. And then numerical analysis. Numerical analysis basically it is how you carry out a study using the help of softwares. Okay, so based on my gap, I have identified the objective also. Now, the materials used for my study. Actually, I have taken two soil samples from two different regions. Then chitosan. Chitosan is actually a byproduct of the fishing industry. So, like if you want to purchase it, you can purchase through Mulsifed, which is actually a part of the fishing. I mean, Kerala government itself, and then or any other ways you can purchase the chitosan. And then coir geotextile, you all be familiar of coir geotextile because it is a natural product, and similar to jute geotextile, you can use coir geotextile. And then concrete mattress, actually it is a mattress which is in the form of actually it is mattress made of like concrete, and then it will be in the form of mattress. Its shape is in the form of mattress. Okay, so these are the properties of the soil sample, first soil sample that I have taken, and I have done various lab experiments, and then I have identified the basic properties that I need to use in the further development of my work. So first, after identifying the gaps, then you have to you have to find out these basic properties. Like if you're using soil or any other material, you have to find out the basic properties. That is how you can carry out different works. So that is very essential. And then this is the gradation curve. So we can see that the soil that I have selected is actually sand. And this is the next soil sample. So as I have selected coastal erosion, my work actually was completely based on the beach side. So all the soils that I have selected is completely sand. Okay, this is the next gradation curve. And this is an example of chitosan. Actually, chitosan, it is similar to sand, very similar to sand actually when you just look with the naked eye. So it is actually a byproduct of the fishing industry. It will be like when you can obtain it from the crust of crab, like shells of crab, shrimp, etc. And then this is the koi geotextile. So koi geotextile we can purchase in bulk quantity, and actually koi geotextile koi itself can be is available in different forms. So koi geotextile, it is available in woven geotextile and non-woven geotextile. So I have chosen non-woven geotextile. So you can use any other kind of products. So first, after identifying the gaps, now you have to carry out the basic property test, and then you have to select your materials. And the materials also, the basic properties should be analyzed. How you have, like, first you have to plan your work, and then how you have to carry out the work. Basis of that, you have to carry out different tests, which is required for the further completion of the work. Okay, so I have also carried out a numerical study, and these are the properties that I have used for the numerical work also. So even in the experimental work also, numerical work, both of them you have to find out these properties. Actually, that is very important, because if you vary even a bit of property, the entire thing may change. So it is essential that you stick on to these properties. Now, this is a basic methodology of how the work is being carried out. That is, since I have done my MTech degree in geotechnical engineering, I have identified a geotechnical problem. Similarly, based on your field of interest, you can select a problem, and first you have to identify that. That is actually done through referring to various literature, and then identifying certain problems. Even a problem in your locality also you can identify and carry out a work based on that. Even the work that I have done, because actually my college was situated in Trivandrum district, that's why I have chosen Trivandrum area. So similarly, you can also vary your work according to your availability and requirement, etc. Okay, so after identifying the problem, you have to collect your materials required for the work, and then you have to do further property test, etc. And then if you're having any test setup, you have to prepare that. Otherwise, just follow how your work is being carried out. That way, just lead your work. And then, since my work was based on erosion, I found out the erosion degree in untreated soils. And then the next stage was to find out the erosion degree in treated soils. Then I have completed my numerical analysis. Okay, so this is the basic setup I have developed for my study. And actually, my work actually, it was, since it was based on coastal erosion, I was trying to replicate a model similar to that of the beach condition, similar to the coastal condition. So I have, um, okay, so I have developed a glass setup. And then this is a wave generator which is used for generating the waves. So we can see there is a motor, and then motor and shaft is there, and that assembly is used to generate the linear motion of the waves. So this I'll show you the full setup. So this is the full setup. There'll be a glass tank, and this is the wave generator assembly. And this is actually a program using Arduino. So Arduino is used to control the whole setup. And then I'll be getting the input based on the variation in velocities and all. I can observe through this reading. And then it is connected to a power supply. Okay, this is how the whole setup is, and the basic methodology actually. I am filling soil in slopes. That is, I have selected 3 slopes, 30, 45, and 60 degree. And those 3 slopes, I'm just filling in the apparatus initially, and then I'll be filling water also. And then after the whole preparation of the soil, filling the water, then I'll be switching on this motor, and then it will be moving back and forth, and then it will be generating a wave. And that wave is used to analyze how the soil is being eroded away. Okay, so the basic test procedure is very simple. That is, first we are measuring the initial height of the soil slope. Then after I have taken a period of 1 hour for the study, and in 5 minute, 10 minute, 15 minute, 30, 45, 60-minute interval, I am measuring the readings, and then the change in height is used to find out the change in slope. And even after this also, you can refer like initially how much quantity of soil was available, and after the completion of this 1 hour also, you can measure how much soil was there. So in both in the slope variation and the quantity, the weight variation also, you can use as a parameter for your study. And this is erosion degree. I have obtained this equation from literatures, and I have use these data to find out the erosion degree. So if the erosion degree is 1, that is, then there will be no change in the original slope and modified slope. So if the erosion degree is 1, it indicates that the soil slope is more stable. As the value of erosion degree is decreasing, we can see that the change in slope is also increasing. So like that, we can identify how much intense the waves are being. Okay, so this is an example of how I have developed my test setup and soil slope in the apparatus. This is 30°, 45°, and 60° slope. Okay, and then after like I have filled water, and then I'll be starting the experiment for a period of 1 hour, and throughout it will be monitored in 5 minute, 10-minute interval like that. Okay. So these are all untreated soil slopes. That is actually, I told you before that I have selected 2 regions for my study, and those 2 soil slopes also, I have carried out these experiments in different velocities. That is actually, I have considered 4 different velocities for my study, 0.06, 0.07, 0.08, and 0.09. These 4 velocities in these 3 soil slopes in 2 different soil samples I have done for my study. So after just doing the untreated studies, I moved on to treated studies. That is to obtain a comparison. So after finishing the untreated soil samples, then I moved on with the chitosan treated soil slopes. So the chitosan which I shown you before was mixed with the soil sample in an optimum percentage. That is, optimum percentage actually we are even in any cases also optimum content, actually it is being found out to make it more economical. That is, we have to obtain more strength also, as well as the whatever product we are using, it also should be economical. So that is why we are adopting the optimum percentage. Also, I hope you are aware of the compaction curve and all. So in optimum dosage, you can see that the strength will be more, and then if it is beyond that, or if it is lesser than that, the strength will be less. So identifying the optimum percentage is very important when you're using admixtures. Okay. So this is the chitosan treated soil slope. So I have taken the soil sample and mixed it in optimum dosage along with the chitosan, and then I have filled it in this apparatus, and then similarly for 1 hour I have taken my study. And the coir geotextile I have shown you before, actually it was cut into the whole roll of geotextile was cut into small pieces, and I've used it as a cover. Chitosan actually I mixed it with the soil sample itself because the texture was similar, but since the coir was entirely a different product, I just used it as a cover. Okay. So in order to carry out your work, actually basically you can rely on different trial and error methods. Actually all the theories or all the facts that we are using right now were once a trial and error. Okay, so all these were developed through trial and error methods. So it is okay that you can use trial and error method, but you have to just confirm it. Okay, so after all these experiments, I have obtained the result. Actually, in order to select the location for my study, I have relied on GIS data. So since my time for the work was limited, I hadn't conducted GIS studies, but instead I referred on to GIS data that were already available. So that is where from which I obtained this degree of erosion of our state. So we can see that our Indian coast itself, 45% of the Indian coast is under the eroding category, and other percentages you can see here. And even the Kerala coastline also, it is 52% under the highly vulnerable category. So like when we are referring this data, we can obtain, like we can understand which all places in our state or in our country is vulnerable to erosion. So based on that, I selected my region for my study. Okay, when you are carrying out a work, you can also refer any basic data. Okay, from that data, you can identify the field or the location you have to carry out your study. Okay. As I mentioned earlier, I've taken 4 different velocities for my study, and then for 1 hour, I've conducted my study, and each like 5-10 minutes, these intervals I've noted, and then we can see the erosion degree. As I told you earlier, the erosion degree, when it is 1, it is more stable, and you can see as the time is passing, you can see the erosion degree is being reduced. Also, the wave velocity, like when the velocity is being increased, you can see the erosion degree is drastically changed, which means as the intensity of wave is being increased, the amount of soil being eroded away also increases. Okay, so this is just the graphical representation of the table that you have seen before. And okay, this is just a sample. Actually, I've done the studies both on both of the samples, like on S1, that is on the first soil sample, and also on the S2 sample. Okay. Okay, these are some of the graph. Like you can see for the 0.06 meter velocity, for the first velocity, all these 30, 45, and 60 degree slope in both the soil samples, you can see them. And similarly for 0.07, 0.08, and 0.09. So we can see that as the velocity is being increased, you can identify how much the degree of erosion is being increased. Actually, the fact that I observed while carrying out my experiment is that this 0.06 and 0.07, they were actually showing similar result, and 0.08 and 0.09 are showing similar result. Also, in my study, I came to identify that the S1 soil sample, that is the minimum column soil sample, was more prone to erosion. That is, it might be due to variation in properties. Actually, the cohesion and frictional angles of the S2 sample was higher. So it offered better resistance against erosion. So when you are also carrying out various works, you can identify. You will be able to identify how different samples are reacting to different components, different admixtures, etc. Even if you are carrying out an entire different study, like maybe like strength test or load characteristics in like and so on, even that time also you can see different samples react to like different components in different ways. So you can come into conclusion how a particular sample will behave in a particular way, and so on. You can identify all those things. Okay. So actually, after first you identify your problem, then you move on to how you have to execute the project or the work, and then you have to identify how you have to tabulate your result. So in from a single experiment itself, you can come into different conclusion. I told you that I just relied on a simple method of testing, but from that simple method of testing itself, I have obtained various kind of conclusions. So that is how you have to learn. You have to interpret your data in different ways. So it will be easily understood both by the observer and ourselves also. Okay, so like before I shown you on how the soil samples is reacting to different velocities, and this graph is an explanation of how the slope, the effect of velocities on different slopes we can identify from these data. In the 30-degree slope, you can see how all these velocities and soil samples is behaving, and similarly on 45-degree and 60-degree slope. Okay, now after completing the untreated studies, I moved on to the studies using additives, that is chitosan and core geotextile. So this is also a comparison actually. You can see that when the extreme case, that is in the case of 60 minutes, in the peak velocity, you can see initially the value was actually 0.11. And when I used chitosan, you can see that it is increased to 0.31. Similarly, for the S2 sample also, 0.11 is increased to 0.35. So Hence, like in all the readings, you can see there is an increase. So we can conclude that when we're using this chitosan product, it is actually offering better resistance to the soil sample. Similarly, in the 45-degree slope, 60-degree slope. Okay, now after chitosan, the next set that I have to carry out, the next set of experiment that I have to do was on coir geotextile. So coir geotextile also, we can see that the initial value was 0.11. When I use the coir geotextile as a soil cover, you can see the values increased to 0.66. That is almost 6 times it is improved. Here also we can see 0.73. So more than 60%. So this 60% improvement, the 6 times improvement is observed in the case of extreme case. So all these data will be above that. So in the minimum, that is in the extreme case itself, when I used coir geotextile, it is providing a result of 6 times improvement. So we can see that if we can understand that the coir geotextile is actually a very good option in reducing the effect of waves. Okay, similarly 45-degree slope, 60-degree slope. Now this is a comparative data. So in the first table, you can see untreated soil samples, then chitosan 3-day. That is actually, I told you that we can try out different trial and error methods. So during my experiment, actually I used first, initially I mixed the chitosan soil sample with the soil, and then I just used it directly. But like I also tried another method, that is I mixed the soil sample and kept it for 3 days. Like similar, I think you all will be aware of like curing period and all. So similar way, I just tried it out for a period of 3 days. So I came to understand that there is actually a very good improvement in the values. So in the S2 soil sample also, you can see the values are improved when I have waited for a period of 3 days. So I already mentioned you that this chitosan, it is actually a biodegradable product. That is, it is obtained from the shells of shrimp, crab, etc. So it is actually safe to use in the soil, use along with the soil. This coir geotextile is also a natural product, and that is also, it is very safe to use, and it is also easily available. Okay, so you can see the improvement of values. And this is just a graph. And if you look into this graph, you can see this is the initial soil samples. And after using this product, we can see the value is actually much higher. So all these amount of soil we are actually saving. So the amount of soil being eroded away is being reduced. Okay, now this is in the case of 45-degree. And this is in the case of 60-degree. So in the 60-degree case also, we can see actually there is a very good improvement. Okay, so that was all about my experimental study, and this is numerical analysis. Actually, why you have to conduct a numerical study? Because in experimental studies, actually, there will be many limitations. Even though I try to replicate the field conditions of a coastal region or a beach side, it is actually very much difficult. Like you can imagine how big the coastal region is and how small the laboratory is. So exact replication is actually a very difficult task. So in that cases, like when it is difficult to replicate all these field conditions, you can adopt for the numerical studies. So numerical studies also like it will help you develop like various kind of result, like various amount of result and various number of result also you can develop from this numerical study. But the only thing is that you have to properly identify how the like how the method is being carried out in order to use for a numerical study. Like numerical purpose, if you are using a structural software, there are various softwares like StatPro and ETABS, etc. And then the software that I used is Plaxis, actually. Plaxis 2D. Plaxis is a software which is used for geotechnical soil-related studies. You can find out the bearing capacity, settlement, etc. Per water pressure, and many parameters you can find out from these numerical. That is actually a very big advantage of numerical studies. That is, even though many conditions, like the amount of condition that you can use in lab studies will be very much limited, but in numerical studies you can develop a various amount of result. So that is the main advantage of numerical data, but you have to be sure that the results you obtain are accurate, and you have to have a proper understanding how you have to interpret those data. Okay, for that, before carrying out a numerical study, you have to go through thorough literature study. You have to you have to collect similar literatures available on those particular topic, and then you have to cross check. You have to carry out a trial, and then you have to verify that you're matching with the result of the numerical site. Okay, so but in my case, actually, the study was very limited. So this was actually a gap, and numerical study on this data was very limited. Only one or two literatures I could find out. So for me, in my case, actually cross-checking the literatures was quite a difficult task because the literatures were very limited. So I did not go for validation. I just conducted this experimental and numerical as two different study. But if you're having proper validation literatures, then you can carry it out as a validation study. That is, you can conduct the experimental study as separate, and then later you can just compare it with the numerical data, and then you can make sure that both of them are matching. That is how you carry out a validation. Okay, so for that, in my case, I developed this 30-degree, 45-degree, and 60-degree slope in the Plaxis software. You can see this is the geometry similar to the experimental setup I have developed, and this is the mesh generated. Mostly all of the numerical softwares are based on these meshes and all. So this is the deformed mesh, and then this is the untreated soil. So it's just the soil, and this soil actually we can input those parameters. I have already shown you that before. Those parameters you can input, and then you can simulate according to different various conditions, various wave conditions, various time intervals and all. You can simulate. Okay. Similarly, this chitosan and for chitosan also, since I have mixed the chitosan along with the soil in the experimental study. Similarly, here also I use the chitosan, soil chitosan mix properties I have used here. And then when coir geotextile, similar to the experimental setup itself, I have modeled it as a geotextile. You can see that. And you can see how the slope is behaving. Now this is the proposed concrete mat. Actually, I couldn't do this for my numerical study, experimental study. Only numerical study I've carried out for concrete mattress. That is, I already mentioned you, concrete mattress, it is actually an impermeable mattress, and then it will be laid similar to the coir geotextile itself. You can lay this on the shore region, or the wherever you want to protect the soil from the action of water. You can just use it. And actually, when I carried out my numerical study, I came to a conclusion that concrete mattress was providing more better resistance against soil erosion, even comparing to the coir geotextile, because it is actually concrete, and then it will definitely provide better result. But the thing is that you have to think about the sustainability and like economical benefits and all. That's why I am preferring more coir geotextile. Okay. Now similar, all these slopes I've modeled. Okay. So this was basically my study. And then the conclusion that I came from my study was that the identification of the regions for my study. Actually, I have obtained that through GIS data analysis. When you are doing also, you can carry out different studies and then come into a conclusion. Then I found out that the erosion of Menamkulam region was found to be lower than that of Pundara. That is, the first soil sample was more prone to erosion compared to the second sample. So even in your case, when you're carrying out a work, even in your BTech final project, you will have to carry out in different ways, and then you can compare. Like if you're selecting two samples, you can compare which is offering better resistance or which is having more strength, and all those properties you can compare. Even basic parameters like permeability or strength characteristics, all those you can compare. And then, okay, then velocity. We can see that as the velocity is being increased, more amount of soil was being eroded away. Okay. Now, okay, so from all those data, the best method that I came to conclude was that coir geotextile, because it was offering more than 60% erosion resistance in all the cases that I considered. Okay. Okay. Now the scope for future work. Actually, I have selected only 2 regions for my study, and only 2 methods or 2 or 3 methods only I have selected for my study. So this same procedure itself can be like you can extend it to different field soils, or by varying the different parameters, or by using different kinds of additives. Like instead of chitosan, you can use various other various other biopolymers, or maybe any other additives you can use. And like other than the coir geotextile, you can use coir in different forms like coco logs, coco pits, like different products are available. You can try out using that also. And okay, so these are some of the examples. Actually, in real life also, you can use it for beach or bank protection. Even slope protection, I think you might be aware of, like in vegetative areas and all, we using jute geotextile and coir geotextile in order to prevent the soil from being eroded away. That is actually, they are using it as a protection against the rainfall. But in this case, from the wave attack, or likewise, you can carry out. And like similarly, if you even like when you have to do a work, even you can refer to your seniors or any other works, and then you can identify the gaps. Like some in all the works, there will be some areas that are missed out. You can refer to that, and then that also you can incorporate into your work. Actually, research is something that is continuous. It is not something that is you're doing it for your just final semester and then dropping it. It is not like that. Like you can refer to previous works, and then you can try it out, and then you can bring out various methods, various suggestions you can do, and then that is also a new work. Okay, so these are some of my publications, and I have participated in few of the conferences. And then, okay, and then Indian Geotechnical Conference also, my abstract has been accepted, and then the paper is currently under review. And these are like, I have received 2 awards for my project. That is, it was selected as best paper in 2 conferences. And okay, these are some of my references that I've done for my study. Okay, and thank you. So I hope like you all have got an idea of how to carry out research work.